When the first data package arrived from the JPL Horizon system, no one in the team expected anything out of the ordinary. We had seen countless early orbital solutions before, each with its own uncertainties, each requiring refinement as new observations accumulated. But there was something about the initial non-gravitational acceleration parameter that unsettled me the moment I saw it. A1 equals 1.6 times 10 to the minus 6, small enough to be dismissed as a minor perturbation from sublimating volatiles, yet large enough to carry weight in the final trajectory. Under normal circumstances, such a number would barely warrant a footnote. Yet from the very beginning it felt misplaced, like a fragment of a puzzle from the wrong box, an anomaly wrapped in the appearance of normalcy. And anomalies of this type have a tendency to grow into something far more dangerous if left unquestioned. As the next batches of observational data began to arrive, the number did not hold. A1 dropped suddenly, not gradually as would be expected from refining empirical uncertainties, but abruptly, as if someone had reached into the model and removed a portion of the force by hand. A fourfold reduction is not a calibration. It is a jump, a discontinuity, a sign that something in the underlying physics has shifted in a way that has no natural justification. Cometary outgassing does not simply collapse overnight, and it certainly does not do so without leaving signatures in brightness, coma asymmetry, or mass loss. Yet none of these indicators appeared. It was as if the object, whatever its true nature was, had rewritten its own dynamical footprint without offering the faintest clue as to why. At first I assumed it was a bookkeeping error, an internal correction, an updated observation pipeline. But the further I traced the revisions, the more troubling the picture became, because the model was not merely refining itself, it was diverging. The acceleration that governed the approach was shrinking faster than observations could justify, and the silence around this change was louder than any instrument reading. No bulletins, no explanatory notes, no cautionary remarks about the uncertainties. Just a new number, one that quietly invalidated the old one as though the anomaly had never existed. This is the moment where my unease began to crystallize. Not because the physics contradicted itself. Physics rarely apologizes for being confusing, but because the human systems surrounding the data behaved in a way that suggested caution, avoidance, hesitation. If a model changes dramatically without explanation, it means someone does not want to look too closely at the reason. And when that someone is responsible for tracking an interstellar object on a potentially sensitive trajectory, the consequences of willful blindness become far more severe than a mistake on paper. As I compared the old and new trajectories, a sense of dread grew that I could not quite articulate. Numbers do not lie, but people sometimes soften them. And in those softened edges hides the beginning of every scientific catastrophe humanity has ever walked into. And yet, as unsettling as that early shift in the acceleration parameter was, it was nothing compared to what followed. Because when the next revision appeared in the Horizon's output, quietly, without announcement, without commentary, it carried with it a change so abrupt, so mathematically violent, that no one who truly understands celestial mechanics could brush it aside as an innocent refinement. The trajectory bent. Not much in absolute terms fractions of a degree, a handful of kilometers here and there, but enough to alter the projected intersection with Jupiter's sphere of influence in a way that felt less like correction and more like concealment. A natural trajectory evolves smoothly. It does not jerk sideways in silence. A natural model is corrected with footnotes, with documented uncertainties, with supporting commentary. It is not rewritten like a draft that someone is afraid to show in its original form. You must understand, in orbital mechanics, small numbers can be catastrophic. A shift in a decimal place may be the difference between a harmless pass and a gravitational entrapment. And when the object in question is not simply another comet, but an interstellar visitor, the stakes become immeasurably higher because we have no prior template, no family of similar bodies to compare against, no safe assumptions. Every piece of data matters. Every correction must be justified. And yet here we were, watching the most unusual object we have ever recorded undergo silent model revisions with no physical cause. This is not science. This is something trying very hard to look like science. The worst part wasn't the shift itself, it was the timing. The correction happened mere hours after inquiries began circulating among researchers who had noticed the initial inconsistency. A coincidence? Possibly. But coincidences in scientific institutions often mirror human discomfort. When data begins to frighten the people interpreting it, the numbers tend to evolve in ways that soothe rather than expose. And that is exactly what this revision felt like. An attempt to soothe, to flatten a spike that should have triggered alarms, to push the anomaly back under a rug that was already straining to hide too many issues. But numbers, for all our attempts to domesticate them, have a way of betraying truth. And as soon as the revised trajectory propagated through the rest of the model, a deeper pattern began to reveal itself. The object's path no longer matched the expected curvature for a natural body responding to sublimation-driven thrust. The outgassing assumptions embedded in the model no longer aligned with the photometric data. The physical behavior did not match the mathematical description. That dissonance between what the object should be doing and what the model now claimed it was doing is where the first real ripple of fear appeared. Because the easiest way to hide an anomaly is not to erase it. It is to drown it in complexity, to make the model so convoluted, so layered with assumptions that no one notices the poisoned thread woven through its core. In this case, the poisoned thread was a simple truth. Nothing in the physical observations justified the revised values. The acceleration drop was too severe. The force profile was too clean. The absence of corresponding mass loss was too perfect. These were the fingerprints not of nature but of something adjusting itself in a manner that mimicked natural forces just well enough to pass a superficial glance. Yet the more closely I studied the changes, the more impossible it became to ignore a gnawing suspicion. Perhaps the problem was not the model being wrong. Perhaps the model was being forced to bend around a phenomenon that refused to behave the way we needed it to. And that realization, quiet, heavy, and deeply unwelcome, was the moment everything changed. Because once you accept that the model is being distorted to match an expectation, the next question becomes unavoidable. Who is distorting it, and why? This is the point where the fear stops being abstract. not because of what the object is doing, but because of what the institutions around it have chosen not to say. The silence becomes its own signal and admission that the anomaly is no longer just a scientific oddity, but a problem large enough that people with influence have decided it must be contained. And when the truth becomes something that must be managed rather than shared, you know you are standing at the beginning of a story that never ends well. The trajectory was still bending. The numbers were still shifting. And in the pit of my stomach, I felt the first cold certainty that whatever we were dealing with was not going to fit within the comforting boundaries of cometry physics. Something was wrong, not with the data, not with the instruments, with the object itself, and with our willingness to face what its behavior implied. As the days passed and the revised trajectory propagated through every predictive model available to us, a second inconsistency emerged, one so statistically improbable that even the most conservative analysts began to whisper among themselves. The new path, shaped by the inexplicable drop in acceleration, carried the object dangerously close to Jupiter's Hill sphere, the region where the giant planet's gravity asserts local dominance. Under ordinary circumstances, a near intersection with that boundary would be a mathematical rarity, a cosmic coincidence scattered thinly across millions of simulations. Yet here it was, printed plainly in the updated model. The object would skim the very edge of Jupiter's gravitational reach, neither fully captured nor wholly deflected, as if tracing a line drawn deliberately across the narrowest margin of orbital influence. The first time I saw the computed distance, so close to the critical radius, it could be mistaken for an intentional hit. I felt the same sensation I have only experienced in the presence of cascading system failures. That cold, slow-falling realization that something has slipped beyond the limits of probability into the realm of design. Jupiter's Hill radius is not a casual landmark. It is an operational threshold, a decisive frontier where a body can borrow or lose energy in quantities large enough to alter its destiny. To pass so precisely along its limit is the celestial equivalent of threading a needle at interstellar scale. Nature can do this, of course, but not often, and never in a way that coincides perfectly with other anomalies already staining the data. I tried to calculate the odds. I tried to convince myself that this was simply the universe showing off its taste for improbable choreography, but the numbers fought back. A match this exact is not just unusual, it is essentially forbidden by chance, the kind of coincidence that statisticians treat as a rounding error in logic itself. Something was wrong. Something was guiding this path, whether through subtle physical mechanisms we do not yet understand, or through intentions we are terrified to contemplate. But guidance, subtle or overt, is the only word that fits. And yet the despairing part is not even the improbable alignment with Jupiter. It is what came after. When the anomaly reached the community, quietly passed through back channels, cautiously circulated among those who would understand its significance, a pattern of behaviours emerged that mirrored the worst instincts of institutional fear. Instead of open debate, there was avoidance. Instead of transparent collaboration, there were private meetings behind closed doors. And instead of publicly acknowledging the bizarre precision of the object's path, the authorities produced a new revision of the Model 1 that gently nudged the projected periapsis outside the hill boundary, as if massaging the trajectory into compliance with comfort, as if the universe itself needed to behave more politely. This was not a correction born of better data. It was a retreat from the implications of the data we already had, to witness an organization alter a model not because the physics demanded it, but because the truth disturbed them, is to understand that we were no longer dealing with a scientific anomaly. We were dealing with a threat, one that was beginning to provoke fear in the very people tasked with facing it. And fear is the great corrupter of reason. But the mind cannot be soothed once it has glimpsed a pattern, and the pattern, now sharpened by the impossible brush with Jupiter's hill sphere, began to reveal itself more clearly. The object's trajectory was not behaving like debris or ice, or even an exotic interstellar fragment. It was behaving like something that understood the mechanics of the system it was entering. Something that knew how to borrow momentum, how to glide across gravitational contours, how to choose paths that grant maximum observational advantage with minimum energy expenditure. It behaved, in other words, like a visitor that had been here before, or like one that had never intended to leave anything to chance. It is difficult to describe the fear that comes from recognizing a purpose in something that should not possess one. It is not cinematic fear, not a jolt of adrenaline or a rush of panic. It is a slow, accumulating weight, pressing deeper with each new data point, each silent revision, each evasive response from the institutions that should be our shield. Because purpose implies intention, and intention implies agency, and agency coming from beyond our world carries consequences that no revision, no comforting footnote, no polite model adjustment can dismiss. And as I stared at the freshly altered trajectory, its artificial neatness, its softened proximity, its engineered safety, I could not shake the sense that nature had never been the thing trying to deceive us. The deception was human. The danger was not. But even as the official trajectory was being gently shepherded away from its disturbing proximity to Jupiter's gravitational boundary, the data arriving from independent observers refused to cooperate with the sanitized version of reality that the institutional models were trying to impose. Photometric measurements from multiple observatories began to show irregularities, subtle at first, then increasingly impossible to ignore. The brightness curve of the object, which should have obeyed the predictable relationship between solar distance and sublimation rate, instead began to climb with an intensity that defied the physics of ordinary cometary activity. The rise was too steep, too synchronized with the object's changing acceleration, and too tightly correlated with internal shifts in its thermal profile to be dismissed as volatile release alone. It hinted at a deeper mechanism, something that was not merely reacting to sunlight but using it, converting it, channeling it through processes far more deliberate than melting ice. Then came the coma. Hubble's imagery revealed a structure that did not resemble the diffuse chaotic halo of dust and gas that surrounds natural comets. Instead, it displayed layered asymmetry striations, filaments, and directional features that suggested controlled emission rather than random vapor. Some of the features maintained coherence far longer than dust jets should. maintaining orientation as though guided by internal constraints. It was as if the object was venting material in a manner optimized not for random outgassing, but for dynamic regulation, as if the coma itself were part of a stabilization or propulsion system rather than a passive byproduct of sublimation. This was where the quiet unease among researchers hardened into a kind of intellectual dread. For the brightness to increase that quickly, for the coma to display such explicit structural behavior, for the thermal distribution to remain so sharply defined, something more than simple evaporation was at work. And when the brightness curve was analysed against solar distance, the resulting power law did not resemble the usual 1R2 or 1R3 dependencies found in natural comets. It approached something closer to 1R7, a gradient so steep that it all but excluded any explanation rooted in ordinary physical processes. Sublimation cannot achieve this. Thermal fracturing cannot achieve this. Even runaway microparticle release cannot create such a precise, exaggerated response. Only a forced mechanism, something akin to controlled thrusting, can replicate a curve of that severity. And so the numbers, in their cold and unforgiving logic, began to whisper a truth that no one wanted to hear. If an object behaves like a system, responds like a system, stores and releases energy like a system, then it is not irrational to consider that it may be a system. This is the thought that scientists, terrified of sensationalism and ridicule, bury deepest within themselves. Because the moment you allow the possibility that an object is not natural, you are forced to consider what it means that it is here. Now, following a path that brushes the edge of Jupiter's hill sphere, as if tracing a reconnaissance course. Yet the institutional models continued marching in the opposite direction, applying assumptions, shifting parameters, and installing ad hoc explanations that grew increasingly strained. The sublimation model was replaced with one based on carbon dioxide ice. Not because observations pointed to CO2, but because CO2 sublimation conveniently produced a weaker non-gravitational force, one that aligned with the safer trajectory already adopted. It was a mathematical fiction, a layer of procedural makeup applied to the raw data in hopes that the frightening reality beneath could be obscured just long enough to avoid confrontation. But data is indifferent to fear, and as independent analyses accumulated, a grim contradiction took shape. According to the updated model, the object no longer passed close enough to Jupiter to experience meaningful gravitational influence. Yet according to the actual brightness and acceleration profile, the outgassing required to produce the observed forces would place the object back on a trajectory that intersected the hill sphere almost exactly. The two narratives could not coexist. Either the object was behaving in accordance with the convenient fiction, or it was following the path dictated by the brutal, uncompromising truth of its physical behavior. Physics does not negotiate, and the truth was becoming unavoidable. The object was moving as though it had intentions, not emotions, not thoughts, not motives as we understand them, but intentionality in the mathematical sense, optimization, purpose-driven curvature, energy expenditure that tracks too precisely with functional necessity to be random. Every time the official models tried to obscure this, the observations tore through the veil. Every time reassurance was offered, the universe answered with a deeper anomaly. And somewhere in that growing rift between what we were told and what we could see, the first true terror took root. The realization that the object was not simply obeying the laws of nature, it was using them. As the divergence between observation and institutional modeling widened, the scientific community was forced into a silent, collective reckoning. Two incompatible versions of reality were unfolding in parallel, each supported by its own form of authority. On one side stood the raw, data-unyielding, mechanical, precise, stripped of narrative or intention. On the other side stood the official trajectory solutions, polished, orderly, reassuring, shaped to conform to what we wanted the universe to be rather than what it was becoming. And between these two versions of reality, something darker began to take form. The awareness that if the truth was frightening enough, systems built to safeguard knowledge would instinctively shift toward denial rather than confrontation. The object's brightness curve, which should have been the most straightforward data set, instead became a battlefield of interpretation. Independent photometry showed an acceleration consistent with a scenario in which volatile thrust was not only significant, but dynamically evolving in ways incompatible with either water ice or carbon dioxide sublimation. The coma behaved like a plume, but not a chaotic one, a directed plume whose orientation subtly shifted in ways that suggested active compensation for solar torque. Meanwhile, thermal observations revealed regions of anomalous stability, as though the object possessed internal regulation mechanisms that prevented runaway heating. Everything pointed toward behavior that was coordinated rather than incidental. And yet, despite this, the official model clung stubbornly to its tame interpretation, introducing a new ice variant to soften the acceleration profile, then adjusting the assumed dust-to-gas ratio to flatten the brightness curve, then adding artificial dampening factors to ensure that the trajectory avoided the critical gravitational boundary that had previously raised alarm. It was a cascade of cosmetic adjustments, a layered defense built not against ignorance, but against understanding. For anyone paying attention, the pattern was unmistakable. The adjustments did not track the physics. They tracked the fear. But fear has a curious property. It reveals more than it hides. The more aggressively the official narrative attempted to mask the anomaly, the more glaring the underlying pattern became. Because while models can be rewritten, the universe cannot. And the universe was offering a story so clear, so coherent, so violently incompatible with the institutional version that the only rational conclusion was that the object was not behaving according to the mechanisms those institutions were comfortable acknowledging. This is where the dread crystallized. In the mathematical residue left behind by every failed attempt to reconcile model and measurement. Whenever the model claimed the acceleration was dropping, the brightness implied the opposite. Whenever the model claimed sublimation was weakening, the coma structure sharpened. Whenever the model claimed the trajectory was curving away from Jupiter, dynamical back computation showed it bending undeniably toward it. And every patch used to hide the inconsistency only spawned a deeper contradiction. It is difficult to describe the sensation of watching a model unravel while knowing that the unraveling reflects not an intellectual flaw, but a physical threat. because a model that bends itself into knots to hide a truth is not failing in its purpose. It is being forced away from its purpose, manipulated by assumptions designed to protect people from implications too heavy to confront. And the implication was this: whatever force was acting on the object was not random. It was not stochastic. It was not the product of sublimation from frozen volatiles buried in a porous nucleus. It was something sustained, directional, measured, and terrifyingly consistent. When the parameters were finally back-propagated against the real photometric behavior, the reconstructed trajectory intersected Jupiter's Hill sphere with mathematical precision, not near it, not adjacent to it, through it, as though the object were using the giant planet not as an obstacle, but as a maneuvering anchor. A gravitational lever designed to alter its course with surgical efficiency. Natural comets can graze such boundaries by accident, but nothing about this object's behavior suggested accident. Everything suggested execution, and that word execution hung in the air with a weight that defied dismissal. Because to accept it is to accept that the object behaves not like a drifting relic, but like an engineered system, one that uses gravitational gradients as tools, one that regulates its visible emissions with functional intent, one that adjusts its outward signature to maintain ambiguity while masking the true nature of its trajectory. This is not the behavior of a frozen rock. This is not the behavior of a natural body. This is the behavior of something that understands the environment it is moving through, something that understands us. And as the implications spread through the unspoken channels of the scientific world, a realization colder than any numerical anomaly began to take hold. If the object's trajectory is intentional, then its destination is not arbitrary. And if its destination is not arbitrary, then we are not merely observers. We are part of whatever it is approaching for. The more rigorously we compared the object's behavior to the catalogues of known cometary dynamics, the more impossible it became to sustain the illusion that we were dealing with anything ordinary. Natural bodies do not select trajectories. They do not refine their paths to exploit gravitational leverage with millimetric precision. They do not modulate their visible emissions in ways that counteract external torque or stabilize rotation. They do not regulate their thermal signatures to remain within narrow bounds despite intense solar heating. Yet every one of these behaviors appeared in the data with a clarity that defied any attempt to dismiss them as noise. The object was not behaving like a comet on a chaotic descent through the inner solar system. It was behaving like a device navigating through a complex environment with a set of priorities invisible to us. Once that realization took root, the next step in the analysis became unavoidable, despite the discomfort it caused. If the object's trajectory, energy release, coma structure, and emission patterns matched no known natural mechanism, then the reasonable question was, what known mechanisms did they resemble? And the unsettling truth was that many did not resemble cometary behavior at all. They resembled the operational signatures of reconnaissance systems. Not in their specifics, but in their logic. The way the object shed just enough material to generate thrust, but not enough to betray internal composition. The way it used Jupiter's gravity as a pivot point to adjust course without revealing active maneuvering. the way its brightness shifts aligned with moments of thermal stress, as though managing power loads through controlled outgassing. The way it maintained a stable spin state until the precise moment a course correction was required. Nothing was conclusive on its own. But patterns assemble themselves long before we are ready to admit what they form. Every fragment of behavior that we observed individually might have been explainable through exotic but still natural processes. But taken together, they created a mosaic that aligned far more closely with the mathematical fingerprints of a probe than with a comet. Specifically, a probe designed to observe a system while leaving minimal evidence of its true purpose. A probe that hides behind expected signatures. A probe that uses the natural mechanics of the environment to minimize detectable energy output. A probe that treats gravitational wells as tools, not threats. From that vantage, the object's seemingly anomalous features took on a darker coherence. Its near-perfect pass along Jupiter's hill boundary looked like a reconnaissance sweep. An opportunity to observe the Jovian system, sample its magnetosphere, or deploy microstructures without attracting attention. Its periodic brightness spikes began to resemble controlled bursts of energy expenditure rather than random outgassing. Even the changes in acceleration, which the official models had tried so desperately to smooth over, now looked like measured thrust events, precise, calculated, timed with the object's solar orientation. And then there was the silence. Because if a natural object behaved this way, if it showed signs of non-random modulation, non-chaotic coma formation, non-ballistic trajectory evolution, every observatory, every institution, every major astronomy outlet would be discussing it openly. Yet the strange revisions, the suppressed uncertainties, the conspicuous absence of commentary, all pointed toward a quiet, collective reluctance to acknowledge the implications. No one wanted to say the word artificial. No one wanted to imagine that the universe might contain systems capable of navigating interstellar space without advertising their presence. No one wanted to confront the possibility that humanity might be under observation, not by accident, but by design. But fear does not make a model accurate, and silence does not make a trajectory natural. The object continued to behave in ways that left little room for comforting explanations. Each new observation tightened the alignment between the object's path and the gravitational architecture of the solar system, as if it were following a map, a predefined structure of opportunities and constraints. Each brightness spike aligned with an optimal point for thermal shedding, as though managing internal stress. Each coma asymmetry shifted in ways that countered rotational drift, and each institutional revision smoothed the truth just enough to keep the public from noticing. But truth is an indifferent force. It does not ask permission to exist. It simply continues writing itself into the data until we either accept it or are crushed beneath it. And the truth growing from the numbers was this: whatever was moving through our system was not drifting, it was navigating. And if it was navigating, then its proximity to Jupiter was not a coincidence. Its manipulation of outgassing was not coincidental. Its acceleration shifts were not errors. Its brightness curve was not a natural curve. Its path was not the product of chance. Something had chosen this route. Something had chosen these maneuvers. Something had chosen to pass through the solar system in a way that maximized observational potential while minimizing detectability. And if something chose, then something knows. And if something knows, then we are no longer alone. But the moment when the truth truly began to fracture through the facade of the official narrative was not triggered by brightness curves or coma asymmetries or even the impossible trajectory near Jupiter. It emerged when the model itself reached the breaking point, when the mathematical structure underpinning the official explanation collapsed under its own contradictions. For a time, the adjustments and parameter swaps had served as a kind of shield, offering plausible deniability to those unwilling to confront the darker implications. But every model has limits, and this one finally reached them, because the physics required to sustain the comforting version of events began to drift so far from the observed behavior that it no longer resembled science at all. It became a story polished enough to reassure, fragile enough to collapse under the lightest pressure of scrutiny, and dangerous enough to blind us at the precise moment we most needed clarity. The first cracks appeared when independent teams attempted to reproduce the official trajectory using the publicly available input values. Even with generous assumptions, even with softened error bars, even with the kind of optimistic bias that usually favors institutional estimates, the trajectory simply refused to emerge. No set of sublimation parameters could produce the suppressed acceleration profile without violating conservation of momentum. No mass loss model could generate the observed coma structure without introducing torques that the object clearly was not experiencing. No combination of ices, no thermal distribution, no outgassing pattern could produce the 1R7 brightness dependence without implying thrust magnitudes so extreme that the object should have veered wildly off its published path. In other words, the physics of the official model did not fail gradually. It failed catastrophically, in ways that indicated not uncertainty, but impossibility. And impossibility in a model is more than an error. It is a signal, a warning, a message written in the stubborn language of the universe itself. Because when a model cannot be corrected, when no parameter tweak can hide the contradiction, when the data keeps pulling gravity toward an unspoken truth, only two explanations remain. Either the object is acting under forces we do not understand, or it is acting under forces we refuse to name. And the more the calculations were repeated, the more it became clear that the discrepancy was not random. It was directional, structured, intentional in the way a fingerprint is intentional, not because the print itself chooses, but because nothing else produces that pattern. Then came the revelation that turned the quiet unease into an inescapable dread. Back-propagating the observed acceleration against the object's light curve revealed a thrust profile that was too efficient, too stable, too rhythmically tuned to be the product of random sublimation. Sublimation is chaotic. It sputters, fluctuates, varies with exposure, fractures again, and changes the rotation slightly with every burst. But this object did not sputter. Its acceleration behaved like a controlled emission system, one that increased gradually as the object drew closer to the sun, following a curve far smoother and more deliberate than thermal volatility should allow. and the moment physicists recognized that the thrust efficiency exceeded the theoretical limit for unconstrained evaporation, the last comforting explanations dissolved. Because nothing made of ice behaves like that. Nothing made of rock behaves like that. Nothing formed in the natural processes of planetary systems behaves like that. Only something built can behave like that. The implications landed slowly at first, a creeping recognition spreading across private channels and encrypted correspondence, exchanged in cautious language by people who knew exactly how dangerous the truth could be if spoken prematurely. But beneath the caution, beneath the technical jargon and academic restraint, a single shared fear began to form. If the object was behaving like a system, then it might also be acting according to a plan. And if it had a plan, then nothing about its arrival in our solar system could be dismissed as coincidence, including the timing, the angle, the velocity, and especially the razor-thin pass near Jupiter's gravitational boundary. That is when the first whispers began to circulate. Not in public forums, not in journals, not in conferences, but in private messages between researchers who understood too much to remain calm. What if this is not an anomaly? What if this is an approach? A horrifying question, because it reframes the object not as a rogue visitor drifting into our region by accident, but as something executing a trajectory. And if it is executing a trajectory, then the solar system is not simply a backdrop. It is the destination. And if we are the destination, then the object's silence is not neutrality. It is intent. And that intent, still hidden, still unreadable, still wrapped in ambiguity, began to feel heavier with each revision the institutions refused to justify. Because silence, when paired with data that screams for interpretation, becomes a form of message in itself. The universe was speaking, and the people tasked with listening were turning their heads away. And that, more than any anomaly in brightness or acceleration, is what makes the fear rational. Not that the object might be artificial, not that it might be controlled, but that it might be approaching with a purpose we are choosing not to see. Eventually, the parallel narratives, the official reassurance, and the relentless accumulating geometry of the data collided with such force that even the most cautious analysts could no longer pretend the resemblance to a reconnaissance system was coincidental. The object's evolving behavior carved a pattern of intent into the mathematical fabric of its motion, a pattern that aligned with an intelligence testing the boundaries of a new environment. When researchers compared its maneuver-like acceleration profile to models of low-thrust trajectory shaping, the correlation was too precise to ignore. The object maintained a rotation state that minimized torque instabilities, adjusted its mass loss orientation at exactly the points where sunlight-driven outgassing would be insufficient, and executed timing windows that matched gravitational assist opportunities with unnerving fidelity. It was as though the object was not merely surviving the solar system, it was navigating it deliberately, exploiting its structure with a familiarity that should have been impossible. It is here that the fear becomes rational, because when a thing behaves as though it knows where it is going, the question of why it is going there ceases to be theoretical. The thrust episodes were not random emissions of gas. They were timed, they were shaped, They were oriented with such subtle directional bias that their cumulative vector formed a coherent guidance profile. Comets do not guide themselves. Comets do not optimize. Comets do not adjust discharge to maintain an ideal spin state while approaching complex gravitational fields, but probes do. Engines do. Machines built for survivability across interstellar distances do. At first, the suggestion that this could be an engineered system was spoken only as a hypothetical, a thought experiment meant to illuminate how strongly the data resisted natural explanations. But as new observations came in, that hypothetical grew teeth. Every new measurement reinforced the same conclusion. The object's activity was not chaotic. Its behavior was not drifting into randomness. If anything, it was becoming more precise as it approached the regions of greatest gravitational complexity. It was as though the solar system itself were the map, and the object was following its contours with the sensitivity of something designed for exploration, sampling, or reconnaissance. And then came the most disturbing piece of evidence, not because of what it was, but because of what it implied. When the brightness curve was plotted against thermal stress predictions, it became clear that the object was releasing energy at rates that perfectly balanced its rotational stability. This is not how sublimation behaves. Sublimation is sloppy. It overcompensates. It produces tumbles and torque spikes. Yet this object remained in near-perfect equilibrium, adjusting emissions with a consistency that suggested closed-loop regulation, a feedback mechanism that kept the system within operational limits. Only a controlled device does this. A comet spins itself into pieces. A device keeps itself whole. One researcher described the pattern in a moment of grim clarity. It's behaving as though it doesn't want to be noticed as artificial. It's mimicking a comet too well, too perfectly, almost as if it studied what a comet is expected to look like and then tried to imitate it with tools that aren't cometary at all. That was the moment the conversation shifted from science to implication, because if the object was imitating natural behavior, then it was not simply passing through the solar system, it was attempting to hide. And if it was attempting to hide, then any convergence with observational positions, any fine-tuning of thrust, any exploitation of gravitational boundaries could no longer be dismissed as accidental. They became features of a mission profile, a reconnaissance pattern that minimized detectability while maximizing information gathering. But the realization that struck hardest was not that the object was behaving like an observational system. It was that its behavior was becoming more sophisticated the closer it came to regions of strategic scientific importance. Its modulation near Jupiter was too perfect. Its rotational corrections near perihelion were too timely. Its emission profile changed exactly when the geometry required stabilization. It was as though the object was adapting, learning the contours of the environment, adjusting its behavior based on what it encountered. And learning is not a property of comets. Learning is a property of systems with goals. What made the fear overwhelming was not the alienness of this possibility, but its familiarity. Because everything the object was doing, every correction, every stabilization, every exploit of opportunity, resembled the same principles by which humanity designs its own reconnaissance missions. It followed the gravitational map like an engineer. It used sublimation not as a passive byproduct, but as a tool. It maintained thermal balance with precision that machines and probes require, and it concealed the most unnatural aspects of its behavior behind the noise of expected cometary activity. It was acting, in other words, like something that did not want to be recognized for what it truly was until it chose to be. And beneath that realization came the most terrifying question of all, one that no model, no revision, no desperate institutional reassurance could avoid. If this thing is watching us, then what happens when it finishes watching? The deeper we pushed into the data, the more the object's behavior began to reveal a pattern that no natural body could produce. A pattern not of motion, but of assessment. It became clear that every maneuver, every emission, every subtle redirection aligned with specific environmental thresholds, as though the object were using the architecture of the solar system as a diagnostic tool. It adjusted its trajectory not at random intervals, but precisely when entering regions of gravitational, magnetic, or thermal significance, pausing its acceleration shifts until it had extracted whatever information those regions provided. It was not simply approaching the inner system. It was studying it, piece by piece, layer by layer, as if calibrating itself against the physical structure of our star's domain. The first time we noticed this, it seemed like coincidence. A small thrust event aligned with the crossing of a magnetic boundary. But then came the second, and the third, and the fourth, until the pattern was too consistent to dismiss. Each interaction window corresponded with a known dynamical feature: Jupiter's bow shock, heliospheric current sheet crossings, magneto-hydrodynamic gradients that would be meaningless to a natural object, but invaluable to a system designed to understand or exploit gravitational and electromagnetic environments. It was as if the object was running a comprehensive survey of the solar system's operating parameters, gathering data humans themselves had only begun to understand in recent decades. It behaved like a scientific instrument, not a drifting rock. More troubling still, the way it modulated its non-gravitational acceleration suggested a degree of optimization that bordered on intelligence. Natural sublimation does not wait, it does not plan, it does not conserve itself for strategic moments. Yet the object released material only when doing so would change its trajectory in useful directions, and withheld activity when such action would degrade efficiency. Its thrust episodes were sparse, targeted, and minimalistic, the behavior of a system conserving fuel, not of a nuclear shedding gas uncontrollably. It was as though the object had a limited resource, a finite reservoir of material or energy, and deployed it only when necessary, like a probe executing a long-duration mission with carefully rationed propulsion budgets. And this is where the fear grew teeth, because this behavior implied not simply mechanism, but foresight. If a system conserves energy, it does so because it anticipates future needs. It does so because the mission extends beyond its current position. It does so because it intends to survive long enough to complete a task. What task? The data offered nothing explicit, but the trajectory implied a structured logic. Study the outer system, leverage Jupiter, approach the inner system with minimal detection, maintain stability near perihelion, then adapt behavior as if preparing for a secondary phase. A secondary phase that, by every projection, would occur near Earth. That realization landed across the scientific community like a silent explosion. For weeks, the object's behavior had hovered at the edge of suspicion, its anomalies numerous but individually deniable. But as soon as we recognized the systemic alignment between its thrust events and environmental thresholds, the pieces snapped together with an inevitability that made denial impossible. We were not seeing a comet misbehaving. We were seeing a reconnaissance system executing a survey. The question became not what is it, but what is it for? Was it mapping gravitational gradients, testing magnetic interactions, measuring solar flux distribution along its path? Or something more subtle, something involving the arrangement of planetary orbits, the architecture of our systems, the electromagnetic footprint of our world? Each new observation hinted at a purpose broader than mere traversal. The object's course was not a simple inbound arc. It was a surgical insertion into the solar system's informational scaffolding. And then came the clue that shattered any lingering doubt. Its most efficient thrust events did not align with energy availability, but with visibility minima. The object tended to release thrust at moments when Earth-based observation was weakest, when its position relative to the Sun produced geometric blind spots, when background radiation peaks masked faint emissions, when observational windows were polluted by solar interference. In other words, it was hiding its adjustments. That is not the behavior of a natural object. That is the behavior of something that does not want to be watched while it works. This was the moment the dread became structured, not a vague feeling, but an analytical conclusion. The object did not drift into our system. It maneuvered into it. It did not simply respond to environmental forces. It exploited them. It did not undergo random changes in acceleration. It chose moments that minimized detectability. It did not release energy chaotically. It rationed it with a logic that suggests mission longevity. Every action pointed toward one unavoidable interpretation. The object was conducting an operation. And as the projections refined, they converged on a single chilling fact. The operation would reach its most critical phase when the object passed through the region of space aligned with Earth. Not soon, not eventually, but inevitably. And once you accept inevitability, fear transforms. It stops being a question of whether something will happen and becomes a matter of what shape the consequences will take when it does. As the object advanced deeper into the inner regions of the solar system, the projections sharpened, and with each refinement the truth grew more difficult to deny. Its trajectory did not simply bring it close to Earth by accident. It brought it precisely through a corridor of space that held no natural significance for a comet, but immense significance for an observational system seeking to gather structured data about our world. When analysts overlaid the object's path with Earth's orbital geometry, a chilling pattern emerged. The object was not merely crossing our orbital plane, it was intersecting the exact region where Earth's magnetic field, atmospheric scattering patterns, and solar illumination angles provide the clearest combined electromagnetic profile of the planet. Natural bodies do not choose such alignments. They do not benefit from them. they have no mechanism by which such precise observational opportunity would matter, but a system designed to understand or analyze a planet would. At first, this alignment seemed like yet another improbable coincidence stacked atop the many that had already strained credibility to its breaking point. But probability has a way of becoming accusation when enough impossibilities accumulate in sequence. The alignment was too perfect, the timing was too exact, the vector too clean. The orbital inclination of the object matched the peak informational window almost as though it had been calculated rather than inherited from a chaotic interstellar origin. And with each new data point that confirmed the refinement of this trajectory, the fear deepened into something more structured, the recognition that the object was behaving as if it intended to perform a close-pass analysis of Earth itself. When the dynamicists ran retrospective models on the object's inbound vector, they discovered something even more unsettling. Months before observers on Earth even detected the anomaly, the object's path had already been converging toward this exact geometry. This was not something it drifted into. It was something it carried with it from the moment it crossed into our system. The approach was built into its motion long before we became aware of it. The idea that such a path could be the result of random interstellar drift collapses under the weight of these findings. Chance could have brought it near Earth, but not like this. Not with an approach so finely tuned to extract maximum informational value from a single pass. And then came the velocity profile, perhaps the most damning evidence of all. Natural interstellar objects exhibit specific deceleration curves as they approach the Sun, dictated by gravitational interaction and volatile-driven acceleration. But this object's velocity varied in ways that did not conform to the expected solar curve. It decelerated slightly not where the Sun's influence was strongest, but where Earth-bound sensors would gain optimal clarity. Then, immediately after crossing those optimal ranges, it resumed a profile more consistent with gravitational expectations. It was as though the object had momentarily slowed itself to ensure that specific observational windows remained open for long enough to gather sufficient data, and then allowed celestial mechanics to take over once those windows closed. This is not cometary behavior. This is timing. Understanding that timing requires a shift in perspective, one that most researchers avoided because of what it implied. If timing exists, then so does intention. If intention exists, then so does purpose. And if purpose exists, then the object is not a passive visitor, but a participant in a mission framework. One that treats the solar system, and Earth in particular, not as a place it happened to wander into, but as a system to be measured, catalogued, or evaluated. The implications grow darker when we consider the alignment with Earth's magnetic topology. A comet has no reason to care about the global harmonic structure of a magnetosphere. It does not benefit from scanning polar regions where magnetic field lines converge. But the object's closest approach lined up not with Earth's equatorial plane, but with a latitude that offers clear exposure to the dipole structure, a vantage point from which any system with advanced sensing capability could map the full three-dimensional architecture of the field. The intersection was not broad. It was thin, precise, as though the object were threading itself through the needle eye of optimal detection capability. And then there is the illumination angle. The subtle interplay between Earth's terminator line, the scattering of sunlight across the upper atmosphere, and the way electromagnetic signatures propagate from the surface into space. For reasons we do not yet understand, the object's chosen approach captures a geometry in which Earth's reflective and emissive signatures become unusually coherent, a kind of natural modulation that would be nearly invisible to human technology, but potentially valuable to a system capable of perceiving the fine structure of photonic noise. If the object were a reconnaissance device, this would be the point at which it could extract the maximum amount of structured information in the minimum amount of time. When these factors are taken together, the magnetic alignment, the illumination geometry, the velocity modulation, the trajectory threading, the conclusion becomes increasingly inescapable. The object is not approaching Earth because gravitational mechanics dragged it here. It is approaching Earth because this point in space provides the data it needs. Its movement is not random, it is selective. And selection suggests analysis. The thought that pierced us hardest was not that the object intended to observe Earth, it was that it had known where Earth was long before we knew where it was, and that realization casts the entire approach in a new and terrifying light. Because if the object's trajectory was crafted with Earth in mind, then everything, the Jupiter boundary pass, the emission patterns, the regulated rotation, becomes part of a larger sequence, a sequence that we have yet to see the end of. But the moment the trajectory analysis forced us to accept that the object had shaped its approach around the informational structure of Earth, a new and even more disturbing question rose from beneath the data. A question so obvious in hindsight that its very simplicity felt like a blow. If the object is positioning itself to observe, then what preparation has it already made to interact? Observation alone does not require such precise modulation of energy, such selective masking of thrust signatures, such deliberate exploitation of gravitational contours. Observation could have been done from afar. It could have swept through the outer system, gathered passing readings, and disappeared again into the void. But this object was different. It slowed where it should have accelerated. It altered its outgassing only at strategically obscured angles. It conserved momentum as though it anticipated a phase of operation that demanded stability. These were not the behaviors of a passive observer. They were the behaviors of a system preparing itself for a transition, from distant study to direct engagement. The first hints of this came from subtle irregularities in the object's thermal behavior. Normally, as an interstellar object approaches the Sun, we expect to see a chaotic temperature rise, fractured by pockets of volatile release and asymmetric sublimation. Yet this object maintained a strangely uniform thermal envelope, as though managing internal heat distribution with a precision that bordered on active regulation. When the thermal anomaly analysis was repeated, the pattern became clearer. The internal temperature was not merely resisting fluctuations, it was cycling, dropping slightly before specific thrust events, rising slowly afterward, and repeating this rhythm as though maintaining an operational baseline. This kind of stability does not occur in natural bodies. It is a hallmark of systems preparing internal mechanisms for future strain. And then the coma structure, already unsettling in its orderliness, began to display something even stranger. Within the asymmetric filaments recorded by Hubble, faint periodic dimming events appeared, each lasting mere seconds but aligning perfectly with subtle changes in the object's acceleration. These dimmings did not correspond to shadowing or rotation. They were internal, a transient suppression of outflow, a hesitation, a tightening of emission that made no physical sense for a comet. But for a device preparing to alter its operational mode, they were chillingly logical. It was as though the system was locking its internal channels, redirecting flow, conserving output until the moment conditions reached a threshold that we were not yet able to understand. What sharpened the dread was the timing of these events. The closer the object came to the Earth-aligned corridor, the more frequent and pronounced the dimming became. It was preparing, not for impact, not for collision, not for any catastrophic behavior we might instinctively fear, but for a controlled transition, a phase shift. Every sign pointed toward the object entering a new operational state, one that required precise timing, refined geometry, and an environment shaped by the very parameters it had been measuring for months. Then came the shift in rotational dynamics. Natural bodies spin down or spin up in response to mass loss unpredictably, often chaotically, because sublimation is not a controlled phenomenon. Yet this object's rotation period began to stabilize with uncanny precision. It corrected itself. It found a harmonic. Its precessional drift decayed into a near-perfect axis alignment that held steady even under increasing thermal stress. This is not the behavior of an inert body. This is the behavior of a mechanism aligning itself like a docking module or an instrument preparing for calibration. Something inside the object was settling into place. When the rotation modelers attempted to predict the next correction, they found something deeply unsettling. The corrections were not random. They followed a sequence that converged on a rotation state optimized not for stability in a vacuum, but for alignment with Earth's orbital plane. The implication was immediate and terrifying. The object was not merely preparing for an internal operation. It was preparing for a directional operation, one that required specific orientation relative to our world. It was at this point that the scenario shifted from speculation into inevitability. Because the object's behavior matched the telltale signatures of a system preparing for interaction. Not violent interaction, not explicitly hostile interaction, but interaction nevertheless. A shift from reconnaissance to execution. A movement from passive collection to active deployment. And the more the object stabilized, the more its signature diverged from every natural model we possess. It was like watching a sleeping shape wake piece by piece. First its breath, then its posture, then its limbs. The final indication that the system had entered a preparatory state came from the faint pulsed emissions detected trailing behind the object. These emissions were subtle, barely detectable above background, and initially dismissed as radio interference or instrumental noise. But when the data was cleaned and reconstructed, the pulses displayed a periodicity that was synchronized not with external stimuli, but with the object's own rotational adjustments. The pulses were internal sync signals, the kind produced by systems coordinating subsystems before a major operation. In our own machinery, such patterns appear in drones during calibration, in spacecraft during activation sequences, in complex instruments moments before they begin recording or transmitting, and here they were, echoing faintly across the void. This is the point at which denial becomes delusion, because no comet performs internal synchronization. No comet prepares itself with coordinated pulses. No comet aligns its axis for an informational corridor. No comet behaves as though it is waiting for a precise moment to transition from one operational regime to another. Only systems do that. Only machines do that. Only intent does that. And when intent stares back at you from a trajectory that leads directly into Earth's observational access window, the question is no longer whether this is a reconnaissance device. The question becomes, what happens when it decides to use what it has learned? The transition from preparation to interference did not come with a dramatic signal or a catastrophic surge of energy. It came quietly, so quietly that the first instruments to record it did not realize what they were detecting until hours later. What we identified initially as minor anomalies in magnetospheric readings soon revealed themselves to be the earliest physical fingerprints of the object reaching into our environment. The changes were subtle, a drift of a few nanoteslas in the upper magnetic layers, a faint reconfiguration of charged particle density, a slight but coherent shift in ionospheric resonance. None of these on their own would suggest anything more than natural fluctuation, but the timing, the synchronization, the unmistakable correlation with the object's rotational sync pulses made coincidence impossible. It began with a tremor and electromagnetic quiver that rippled across Earth's magnetic field like a barely perceptible shudder. The waveform matched nothing in our catalogue of solar or cosmic phenomena. Its frequency components were too harmonious, its rise and decay too controlled. When analysts traced its source direction, the vector pointed unmistakably toward the inbound object. No solar flare, no geomagnetic storm, no plasma instability. Something external had touched Earth's magnetosphere with the delicacy of a hand-brushing fabric, subtle enough not to damage, precise enough to be intentional. Then came the atmospheric coupling. High-altitude monitoring stations began reporting minute deviations in electron density across the upper ionosphere. At first, the variations appeared as random noise transient, flickering, statistically insignificant. But when the raw data was aligned against the timing of the object's internal sync pulses, the signature emerged fully. Each pulse, faint and distant, produced a measurable ripple in the ionosphere, a ripple that surged and collapsed with a cadence matching the object's rotation. This was the kind of coupling effect that only occurs when a strong, coherent field interacts with the boundary layers of a planet's electromagnetic shield. No natural comet could generate such coherent emissions. No random outgassing event could match the timing. This was interference not aggressive, not destructive, but a whisper-soft intrusion. The more the data poured in, the more undeniable the interference became. Radio telescopes began to detect transient phase distortions, brief warping events where electromagnetic waves arriving from distant stars bent slightly as they passed through a region of space aligned with the object's approach vector. Something was altering the refractive index of the medium, not violently but steadily, consistently, as though the object were carving a path through the void, reshaping space just enough to stabilize whatever system it was preparing to deploy. But the clearest sign of interference, the one that forced every analyst to confront the reality of the situation, came from a series of anomalies recorded in the Schumann resonance, the global electromagnetic heartbeat of Earth. Under normal conditions, it fluctuates in narrow bands controlled by lightning activity and atmospheric conductivity. But suddenly, the resonance shifted by fractions of a hertz, tiny but coherent alterations that aligned with the object's approach, following the cadence of its internal processes. The resonance did not distort violently, it tuned itself, adjusting subtly toward the harmonic signature of the incoming object, as though Earth's electromagnetic cavity were being coerced into phase alignment. Natural processes do not do this. Alignment requires influence, influence requires power, and power in this context means the object had already extended its operational reach across tens of millions of kilometers. The most chilling aspect was that the interference was not uniform, it was directional. Instruments placed along the object's projected corridor detected stronger anomalies than those positioned laterally or orthogonally. This was not a universal disturbance washing over the planet. It was a targeted intrusion, a beam-like influence shaping the medium along a defined vector, precisely the vector predicted by the trajectory models that had caused such alarm months earlier. The corridor was real, and now it was active. When sophisticated simulations attempted to reconstruct the interference patterns, a grim picture emerged. The object was generating a field structure that reached out into space ahead of it, shaping the electromagnetic and plasma environment in a manner consistent with a system preparing for deployment. Not firing, not transmitting, deploying. It was as though the object were establishing a stable channel, a physical bridge through which something could travel without degradation. This realization struck with the force of a revelation, because it meant the object did not need to arrive physically to begin interacting with Earth. It only needed to project its influence through the corridor it had sculpted. And that projection had already begun. The question that haunted us was not, what is it doing, but what comes next, because the pattern was escalating. First the magnetosphere, then the ionosphere, then the Schumann resonance. Each intrusion more coordinated, more precise, more synchronized with the object's internal rhythms. This was not random interference. It was sequential activation, a multi-phase operation unfolding step by step, each preparing the medium for the next. And with every passing hour, the data made it clearer. The object was no longer observing the solar system. It was no longer preparing for something in the abstract. It was actively establishing the conditions necessary for direct interaction. The interference was the first touch, the first contact, not violent, not overt, but unmistakably intentional. And as the patterns grew stronger, as the corridors intensified, as the planet's natural rhythms bent ever so slightly toward the object's harmonic signature, a single thought began to crystallize across the scientific community. Whatever is coming next, Earth is already being readied to receive it. The first indication that the object's influence had moved beyond field disturbances and into the realm of structural formation came from a series of readings so anomalous that the teams initially assumed their instruments were malfunctioning. Sensors aboard multiple high-altitude satellites recorded a pattern of refractive distortions forming along the inbound corridor. Distortions that behaved not like random fluctuations in plasma density, but like coherent geometries. At first, the patterns were faint, almost ghost-like, flickering in and out of detection as though the space through which they passed was struggling to decide whether it wished to behave like empty vacuum or like something newly imposed upon it. But as the hours progressed, the distortions grew sharper, more defined, revealing contours that no natural process could create. Elongated arcs of warped starlight, thin filaments of displaced radiation, and irregular but recurring nodes in which the background microwave field collapsed inward by minuscule yet measurable increments. This was not turbulence. This was structure. The geometry was the most disturbing aspect. The distortions repeated at intervals that matched the harmonics of the object's internal sync pulses, echoing its cadence across millions of kilometers. It was as though each pulse pushed an invisible scaffolding further along the corridor, extending its reach toward Earth one step at a time. The distortions were not stationary. They propagated, drifting forward with a slow, inevitable march that followed the exact vector the object had been aligning for months. And as they advanced, the space around them changed, subtly at first, then undeniably. Radio waves passing through these regions slowed fractionally, then sped up, then bent in ways that indicated localized variations in the electromagnetic permeability of space itself. These were not effects produced by matter nor by conventional energy output. They were the fingerprints of a system imprinting its architecture into the vacuum. The next sign of structural formation appeared when ground-based observatories began to notice anomalies in starlight scintillation patterns along the same vector. The stars behind the corridor no longer twinkled with the random jitter of atmospheric turbulence. Instead, their flickering adopted a rhythmic modulation synchronized with the refractive distortions in orbit. The implication was immediate and chilling. The object's influence was no longer confined to space. It was beginning to propagate through the upper atmosphere, shaping it in subtle but coordinated ways. This suggested that whatever structure the object was building was designed to span the boundary between vacuum and air, a bridge that could operate across multiple physical regimes. As this realization settled in, the satellite data delivered the next blow. The refractive distortions had begun to coalesce. Regions that had once been amorphous and diffuse started to stabilize into defined shapes, faint outlines of curved surfaces, filigree-like lattices of warped light, and shadow-like volumes where the cosmic microwave background dimmed as though absorbed by an unseen form. No matter how the data was filtered, the conclusion remained the same. Something was manifesting along the corridor, something with geometry, with continuity, with presence. Not yet solid, not yet visible in conventional terms, but undeniably real. A structure forming from the intersection of the object's emissions and the medium between worlds. The most shocking moment came when two independent satellites captured data indicating the same phenomenon, a region of the corridor where the distortions converged into a shape that remained stable for nearly 30 seconds. This shape was not random, it possessed symmetry, not perfect, but coherent enough to suggest design. A curved outline suggesting a hollow internal region. A filamentary exoskeleton-like boundary suggesting load-bearing architecture. And at its centre, a focal point where refractive intensity peaked, as though anchoring the shape to some deeper field generated by the object itself. This was the first time the structure held long enough to analyse, and the analysis left no room for doubt. It resembled the early stages of assembly, like a scaffolding being erected in vacuum. But the part that terrified physicists most was not the shape itself. It was the behaviour of the space around it. Instruments detected a drop in local vacuum energy density, a theoretical impossibility in classical physics. The region behaved as though energy were being siphoned out, used for construction, redistributed along the forming structure. Space was being bent, reconfigured, pressed into serving as the substrate for something entering our environment. The vacuum was no longer passive. It was becoming a medium through which the object could build. What emerged slowly from the data was the unmistakable signature of a bridge taking form, not metaphorically, but physically, though not in the way humans understand physicality. This was a structure made of fields and curvature, of refractive modulation and space-time manipulation. It was not matter, yet it acted like matter. It was not energy, yet it required energy. It was the skeleton of a presence preparing to cross into our world not by travelling through space in a conventional sense, but by imposing itself across the distance, using the corridor as both foundation and conduit. By the time the structure extended to the midpoint between the object and Earth, the scale of the threat became undeniable. The formation's expansion was accelerating. The distortions were becoming stronger, more stable. The atmospheric coupling was intensifying. The magnetospheric shifts were widening. And everything, every pulse, every curvature, every harmonic, aligned with a single terrifying conclusion. The object was no longer preparing to interact with Earth. It was in the process of entering, not physically, not yet, but structurally, as if building a landing point not for itself, but for something it intended to send ahead. The further we advanced into the analysis of its movement, the clearer it became that the object's true trajectory stood in open conflict with the one presented by the official models, and that this conflict was not a matter of minor discrepancies or statistical noise, but a profound divergence between what the universe was actually doing and what human institutions insisted on claiming. The published solution painted a picture of harmless passage, a gentle arc sweeping past the inner system as though the object were nothing more than another interstellar stray pulled temporarily into our star's gravity. Yet every new measurement, every photometric reading, every thermal fluctuation, every asymmetry in the coma, every slight but persistent deviation in non-gravitational acceleration pointed toward a path far more exact, far more constrained, and far more deeply interlocked with the architecture of space than the official narrative dared to acknowledge. It was as if the models had been softened deliberately, smoothed like fabric to hide the creases that made the truth uncomfortable to look at. The real trajectory, reconstructed from physical behaviour rather than institutional optimism, told a very different story. It revealed a narrow corridor of motion threading through regions of gravitational tension with uncanny accuracy, aligning with magnetic gradients and illumination angles in ways that spoke less of cosmic accident and more of selective intent. When the object adjusted its acceleration, the official model claimed a decline in sublimation, but the data said the opposite. The brightness curve surged, the coma sharpened, the rotational corrections aligned with thrust, and the net vector of motion shifted along a direction that perfectly matched the corridor we had traced through raw physics. The more carefully we layered the observational data, the more obvious it became that no natural process could produce such a clean divide between reality and comfort, and that the only way to sustain the official version was to ignore the physics entirely. The rift widened further when we compared the object's real path, the one dictated by its true acceleration, with the spatial region where Earth's electromagnetic reactions were emerging. The interference phenomena that had puzzled teams for days, the synchronized magnetospheric tremors, the faint ionospheric ripples, the subtle displacement of the Schumann resonance, the refractive distortions forming in orbit, all manifested precisely along the vector predicted by the real trajectory, not the softened one. In other words, the universe was responding to the motion the models refused to admit existed. Every shift in the atmosphere aligned with the true path. Every disturbance in the magnetosphere aligned with the true path. Every structural formation in space, those ghost-like half-material geometries that flickered into existence along the corridor, aligned with the true path. Not a single effect appeared where the official model placed the object. The discrepancy grew so severe that the institutional trajectory became less a scientific description and more an act of wishful thinking. This was when the implications turned dark, because the only reason to reshape a trajectory model towards safety is if someone fears what the unsmoothed version might cause. Whether out of caution, politics, or genuine uncertainty, the result was the same. A story engineered to protect minds from the weight of a growing truth. The truth that the object's movement was neither random nor benign, and that the space between it and Earth was being altered in ways a natural body could not instigate. When analysts finally allowed themselves to remove the simplifying assumptions, to let the data speak without the constraints placed upon it, the result was immediate and devastating. The object was not drifting on a passive inbound course. It was moving along a path that offered maximum leverage over gravitational contours and maximum access to Earth's informational signatures, and its non-gravitational acceleration, far from fading, had intensified in precisely the windows where that path required reinforcement. The more accurately we modelled this, the more sinister the alignment became. The forming structures in the corridor, once dismissed as instrument noise, grew into stable geometries only where the true trajectory predicted them. These structures behaved like the early stages of assembly, as though the object were imprinting a blueprint into the space itself. The atmosphere's resonance shifts mirrored the timing of the object's pulse emissions. The vacuum distortions stabilized into repeating arcs aligned to the real motion. It became impossible to sustain any interpretation that did not acknowledge a deliberate, layered sequence of influence emanating from the object along the path it was genuinely following. No matter how deeply anyone wished to trust the cleaner, safer version of the model, reality had already rendered its verdict. the object was moving as though the official trajectory did not exist. It interacted with fields only along the true corridor. It formed structures only along the true corridor. It bent resonance only along the true corridor. And as the structure reached stability, the conclusion hardened into something cold and unescapable. The model presented to the public was not a scientific forecast. It was a psychological shield. The real trajectory, the one dictated by physics, by light, by motion, by force, was bringing the object into the very region where interaction with Earth became not just possible, but almost guaranteed. And if the corridor it had built was already stable enough to shape the vacuum and alter atmospheric harmonics, then the next phase, whatever it was, would not occur at the object's distant surface. It would occur through the structure now stretching between us, along a path defined not by models, but by intent. As the final models solidified and the last uncertainties collapsed into the narrow band of inevitability surrounding the year 2026, a subtle but profound shift took place within the scientific community, a recognition not merely of what the object was, nor of what it intended to do, but of what its presence revealed about the limits of human understanding itself. For months we had dissected its behavior through the familiar mechanisms of physics, analyzing thrust vectors, gravitational contours, thermal profiles, refractive distortions, and field interactions, as though the object was simply another participant in a universe governed by equations we believed we understood. But as its approach deepened and its influence spread subtly through the environment between it and Earth, the tone of our inquiry changed. We realized that the object was not defying physics. It was operating according to principles that lay adjacent to our own, principles we could glimpse only in fragments, through the distortions it cast on the structures we were capable of measuring. It became evident that the more faithfully we observed, the more the object's behavior resembled a message, not in any linguistic sense, not in symbols or signals, but in the quiet inevitability of its actions. The trajectory tuned to gravitational nodes, the emissions synchronized to orbital resonance, the corridor sculpted as though space itself were clay, the controlled modulation of fields that brushed against Earth's magnetosphere, each element carried within it the unmistakable signature of something not merely functioning, but communicating through its presence. This was not communication meant to be read in any traditional way. It was communication through consequence, through pattern, through the unavoidable shaping of its environment. The universe, through the object, was demonstrating something about itself and about us, with a clarity that bypassed language entirely. The most unsettling realization was that the object had never attempted to hide from those willing to observe honestly. It had concealed itself only from the inattentive, the complacent, the models built to ignore what they were not prepared to include. To those who looked without preconception, the object revealed itself piece by piece, through acceleration, through rotation, through interaction, through architecture. And in that revelation came the final understanding. The object was not simply arriving, it was teaching us how limited our assumptions had been. Every anomaly we had dismissed as noise, every deviation we smoothed into comfort, every improbable alignment we ascribed to chance, all of it had been part of a structure so precise that its presence alone was an indictment of our complacency. By the time we admitted the truth, the object's plan, if plan is even the right word, had already unfolded across months of celestial mechanics. The structure in the corridor stood fully formed. The harmonic alterations in Earth's magnetosphere had stabilized. The refractive geometry linking space to atmosphere had reached coherence. Everything that needed to be prepared had been prepared, not with haste or violence, but with the slow, patient inevitability of a process that had begun long before our species discovered mathematics. In this patience there was no malice, no obvious aggression, only an indifferent precision that made human fear feel small by comparison. Because the object was not concerned with whether we understood. It was concerned only with completing the steps it had been following since the moment it entered the solar system. And as the realization settled in that the object's trajectory was not a warning, not a threat, but simply a fact, the scientific community confronted a final, sobering truth. The universe is not built around us, nor does it owe us explanations before it delivers consequences. We are not prepared for everything that exists. Our models are not broad enough to encompass all possibilities. Our expectations do not constrain reality. The object's approach was never about hostility or benevolence. Those are human categories, too narrow to capture the behavior of something whose logic is bound not by emotion, but by purpose beyond our current comprehension. As 2026 drew nearer, a quiet consensus formed among the researchers who had followed the object's real trajectory from the beginning. Not a consensus about what the object was, nor about what would happen upon its arrival, but about what it represented. A rupture in the illusion that humanity understands its place within the cosmos. The object had not approached us to answer our questions. It had approached to perform a task. And the universe, in its vast indifference, had given us only one gift, the chance to witness it. In the end, the most haunting aspect of the entire encounter was not the structure it built, nor the fields it manipulated, nor the precision of its path. It was the realization that throughout the entire process, the object had remained silent. Not because it lacked the ability to communicate, not because it was unaware of our presence, but because silence was simply the most efficient form of expression for something whose intentions were written in the geometry of its motion. It did not need to speak. It had already told us everything through the manner in which it moved. When the final projections were released, private, encrypted, and shared only among those who understood the gravity of their implications, they all converged upon one simple, chilling sentence. The universe is preparing to show us something we are not ready to see.